Okay, here we are. Still continuing with circles. Today we're going to be talking about now some area. So we'll be talking about finding the area of the circle. Yes, the last video we were talking about the circumference, so just like the distance around. So the area of the circle is the product of pi and the square of the radius. So if I draw a circle here, there's the center, there's the radius. So the area equals equal to pi r squared. All right, what's the area of a circle with a diameter of 42 feet? So if the diameter is 42 feet, remember the radius is going to be half of that, so it's 21. So it's pi r squared. If I leave it in terms of pi, I would square the 21, so it's 441 pi feet squared. If I approximate that on my calculator, I get 1,385.4 feet squared. All right. Just like we talked about in the last video about how we can find part of the circumference of the circle, we called it the arc length, we can also find part of an area of a circle, so we can find parts of the pi. So a sector of a circle is a region bounded by an arc of a circle and two radii to the arc endpoints. So here's point A, point B, O right there. So this right here is sector AOB. So if you notice, the vertex is in the middle, and then I have my other endpoints A and B. So theorem 1012 says the area of a sector of a circle. So the area of a sector of a circle is the product of the ratio. So just like before, we're going to take the arc measure, divide it by 360 to tell us how much of the circle that we're looking for. And then we're going to take the product of that ratio and the area of the circle. So again, A, there's B, O. So if I wanted to find the area of that sector, I would take the measure of arc AB, so I'd find the measure of that arc, divide it by 360 times the formula pi r squared. So in the next problem, it says a circle has a radius of 4. So we have some circle with a radius of 4. What's the area of a sector bounded by a 45-degree minor arc? So then there's that arc right there. Remember, the measure of the arc is the same thing as the measure of the central angle. Also remember, when I say the measure of the arc, I'm not talking about the length, okay? So measure of arc, length of arc, different things. The measure is the angle. The length would be the distance of that little section there. All right, so to find that area, I would do 45 over 360, because it's the measure of the arc, over 360, pi, and then I would take that 4 squared. If I leave it in terms of pi, I get 2 pi. Remember, this is area today, so this is inches squared. If I don't leave it in terms of pi, if I multiply it out, then I get 6.3 inches squared. Okay. This one is a little bit different now. So then we have a segment of a circle. So a segment of a circle is a part of a circle bound by an arc and the segment joining its endpoints. All right, so the idea here is that I want to find maybe this piece right here. So again, this would be a segment of a circle because it's bound by the arc there and it's bound by the segment, okay? So what ends up happening here is I end up finding the area of the sector, and then I find the area of that triangle. And then when I subtract these two, I'm left with the segment. So we find the area of the sector, then we find the area of the triangle, and then we subtract those two and we get the area of the segment. So if you want to try these two problems down below on your own, before you watch me do them. You could pause the video right now if you want to wait for me. If you want to do them with me, I'm going to do them right now. So again, first thing I'm going to do, I'm going to pick one of these light colors, is I'm finding the area of this entire sector. Okay, so the area of the sector first. So it's 60 degrees over 360 times pi times 18 squared. When I work all that math out, I'm going to leave it in terms of pi because it says leave your answer in simplest radical form. This is also, basically it's asking for the exact answer. So when it asks you for the exact answer, you want your answer in radical form in pi. You don't. The exact answer means you never rounded anything. Okay, so this is 54 pi. Okay, then the next thing I'm going to do is I'm going to find the area of the triangle. All right, that triangle right there. So to find the area of a triangle, I need 1/2 the base times the height. All right, here we are. This is an equilateral triangle in here. To find the height there, remember the whole side is 18, half the side is 9. So there's a 30, 60, 90 there, triangle inside there. So to help me find that height, 9 is opposite the short, so I multiply by the square root of 3. So the height here is 9 square roots of 3. So that's that height right there. When I multiply everything there, I get 81 square roots of 3. So then the area of the segment, I would subtract these two. If you're leaving it in the exact answer actually looks like this. And then it's inches squared. The exact answer, this is like if you had 54x minus 81y, if it's an x and a y, you wouldn't be able to put them together. So it's the same thing here. You've got a pi and a square root of 3. I'm not putting them together. That is the exact answer. I did not round anything. If I want to round that answer, so when I want to finally round that answer, I can do 54 pi minus 81 square root of 3. So I get approximately 29.3, and again, inches squared. Okay? All right, the other one is a little bit more straightforward. This one, again, we're going to do the same thing. So I'm going to find the area of the entire sector, so the entire piece of the pie. So this is a 90-degree angle, so 90 over 360 times pi. The radius is 4, so I get 4 pi here. The area of the triangle. This triangle is actually a little bit easier triangle. This over here is also 4, okay? It's a right triangle. It's sideways right now, but think about it this way, where this is 4 and this is 4. So the base of the triangle is 4, but the height is also 4. You could find the height like this way, but you're just making it a lot more difficult for yourself. But yet, yes, you could find the height this way and use that as the base and find the area of the triangle that way. It'll still work out to be the same final answer, but you're making the problem more difficult. So this is, if you see that right triangle, just, again, you got a base and a height right there. That ends up being 8. So then the area of the segment, when I subtract those two, again, this is like saying, 4x minus 8, you can't put those together. So I would just leave it like that. If I wanted to round it, I would type it into my calculator, and that's what I'd get there. All right, as you can see here, I'm going to do 2 of these with you. I am not going to do the number 50. You can do those if you want, but you really don't need to worry about it. It's a little bit more involved than the other ones. All right, so we're going to look at 46 or 28 and then 46. So 28. Okay. So 28, I wanted to look at this one just because it's a little bit different, because kids are like, what do I do? Because that whole thing is so big, and we didn't do this one. And We talked about in the notes that you would always subtract the triangle. Sometimes it makes more sense to do the opposite though and to add the triangle. Because if you notice here, this is my shaded area that I want to find the answer of. I don't want that little segment there. So when I do these ones, what I like to do is I like to find this piece of the pie over here. So if the whole circle is 360, if I do 360 minus 60, I've got 300 over 360, so that's this part right here, times pi, 12 squared. And then I could just find the area of that triangle. So basically what I've done here is I found the area of everything. This is the area of everything but this piece of the pie taken out. And then now I'm going to add back in the triangle. So the triangle is 1/2. The base is 12. Now remember, this is just like the one we did in the notes. So we've got 60, 60, 60. Split that in half. That whole side was 12. All these sides are actually 12. I split it in half. So now this angle up here is 30. The half side is 6. 30 is opposite the short. So then the long leg is 6 square roots of 3. So that's the height of the triangle. So in this one, it says to leave your answer in terms of pi in simplest radical form. So right here, when you do all this math, you get 243 pi. And then over here, when you do this math, sorry, I'm looking at, actually, that's not 243 pi. This is 120 pi. And over here, when you do this math, you get 36 square roots of 3. And again, I can't, this is meters squared. I can't put those together because it's like, 120x plus 36y. All right, and then I said we were going to look at number 46. Um, 46 is another one that we could do some subtracting here. You could do each individual one. I like to find the area of the whole circle and then subtract out the hexagon. So in 46, and this one it says leave your answer in terms of pi. So the area of the circle would be pi r squared, so pi 7 squared, so that is 49 pi. The area of that hexagon is 1/2 the apothem times the perimeter. If I have a hexagon, so that line right there they gave me is that radius. Remember in a hexagon, we have 6 triangles that are like this. Here's the radii. So that angle up there is 60. So if I split it in half, half of it is now a 30-degree angle. This side right here would also be 7, but if you don't believe me, this is the hypotenuse to get back to the short leg. This is 3.5, so again, that's half of 7. The height is 3.5 square roots of 3. So right here, I would have 1/2. The apothem is 3.5 square roots of 3. The perimeter, so one side is 7. There's 6 sides, so the perimeter is 42. This ends up being 73.5 square roots of 3. So then my final answer for this one, because I'm going to subtract those two, I have 49 pi minus 73.5 square roots of 3. And again, this is meters squared. Okay?